Yes. So good afternoon, everybody. I want to present the results of comparison of delta C13 and PMC values for 10 Cretaceous to Jurassic dinosaur bones. And the motivation, I will briefly go through the agenda, starting with the motivation why we did such very unusual C14 dating experiments on dinosaur bones, and present the excavation sites and specimens, how the samples were pre-treated, and then I present these results, which will be very interesting to all of you, and finally discuss them, their origin, and arrive at a conclusion and suggestion for further work. C14 has been reported from Mesozoic, Paleozoic, carbonaceous earth material, and original biochemistry, soft tissue, has been reported in fossils, including dinosaurs. This is the work of Mary Schweitzer et al. And others. And we also have a report of Jurassic squid ink, which was verified as original eumelanin. Hemoglobin remnants have been observed in the Tyrannosaurus rex and in the mosasaur. Collagen and phthalocalcine have been reported from a Jurassic Archaeopteryx. Now, what is the reason for these unexpected results? This was one of our basic motivations for following these C14 experiments. This gives you an impression of a Triceratops and Hadrosaur deposit in Glendive, Montana Badlands, where we performed excavations. And this is a specimen of the Triceratops femur bone deposited on sand and clay. And this shows how such a bone is sawed into two pieces in order to extract samples from different points here. This gives you a view on the interior of such a bone, and you see remarkably well preserved fine structures. And here is the interior of a hadrosaur bone, which shows Haversian canals. These are the tunnels for the blood vessels. And this was the sample pre-treatment which we applied, which the laboratories applied, to which we have sent our samples. It's the standard procedure for carbon extraction and cleaning. It will be familiar to several of you. The fossil bone will be crushed. You can have samples up to 500 milligram in mass. And then the CO2 evolves under vacuum, and acetic acid treatment is given. It removes the superficial calcium carbonate, which is one potential source of contamination. And the next step is that sodium hydroxide is applied in order to remove organic contaminants. And then we can apply strong hydrochloric acid in order to sample the bone apatite, calcium carbonate in the bone apatite, which will evolve as CO2, or part of it as CO2, and these CO2 molecules are used for dating with C14. The remaining organics, collagen, this fraction, if it's a sufficient amount, will then further be processed until CO2 or graphite is available for dating. This is a picture of an hadrosaur femur bone from Glendive, Montana, where we were able to extract bioapatite, several hundred milligrams, and even proteins, collagen, were extracted 3.79 milligram in this hadrosaur femur bone. And a C14 measurement by accelerated mass spectrometry performed in 2007 delivered a value of modern C14, a fraction of 5.59%, and the delta C13 was minus 23.7 per mil. Another specimen, this is the Allosaurus from Colorado. Here we also applied the C14 measurement to calcium carbonate from the bone apatite and obtained furthermore 2% of modern carbon, C14, and delta C13 was minus 6.6 per mil. An earlier measurement delivered a higher values, 13.3%. We are not sure what's the reason for that. It could be that this was an older pre-treatment procedure. The Triceratops bone from Montana, where we extracted proteins, collagen, delivered a value of 2.16% of modern C14 and delta C13 of minus 20.1 per mil. This is an overview of all the dinosaurs, of all the PMC values which we obtained for the dinosaurs we have examined. You see that they all range between around 0.7 to 6.5%. And we obtained similar PMC values for different fossils, different bone materials, and different bone regions where we took the sample from. Furthermore, these PMC values are distributed among different deposition depths and do not depend on them, apparently. Let's look a bit more detailed into this overview. If we compare the results from samples of the same bone region, then we obtain a very good concordance between the PMC values. Here is an example of a Triceratops where we extracted both collagen and total organics of the same bone region, and we obtained around 1.5 and 2.2% modern carbon. So this shows all dinosaurs except one where we had used a very, very small sample and which delivered an unusual high PMC value. The next comparison of samples from the same bone region, this is from Hadrosaur. The one value is for total organics, and the neighbor value is the extracted humic acid, supposed to be a contaminant, and both show very similar PMC values. This example, that's a Hadrosaur. Both three samples stem from the same bone region again, and collagen and bioappetite, protein and mineral from this same bone region have concordant amount of carbon-14. And here is an Archocantosaurus from the same bone region. We obtain, in this comparison of organics and bioappetite, a very nice concordance. And here again, from the same bone region of the Hadrosaur, we compared the result of examination with accelerated mass spectrometer and beta mass spectrometer. The main difference is that the former can use only very small sample sizes, and the later very big sample sizes. And of course, there is a resolution difference between the two, AMS being capable of measuring far less CO2, carbon-14. Now this is a summary of the dinosaur delta C13 measurements. And you can observe that the minerals from all samples have concordant delta C13 values between -3 and -10 per mil, with one exception. This one is not understood so far. And then we have the collagen, organics, and charred bone from exterior of the bone, and they all have concordant delta 13 values, C13 values between -17 and -28. This shows an overview of all the RC dating we did, not only with dinosaurs, but also with megafauna and with fossil wood and so on. I hope you can read it. You see this is what you have already seen in the left half, and here are the PMC values obtained for mammoth appetite, for rhinoceros, so for megafauna, and this is for charcoal, fossilized wood, etc. And here we have the matrix on top of the Triceratops is also lying near to where we measured the Triceratops itself. And here are some values for amber, low but detectable C14, and they stem from the Cretaceous to Eocene. So megafauna have similar PMC as their dinosaurs, obviously, in our results here, and the plant fossils have consistently a lower PMC than the dinosaurs. I summarize these results from the dinosaurs. We have examined 10 different dinosaur bones from Upper Jurassic to Upper Cretaceous, and they have shown measurable C14 signals. A similar PMC was observed between 0.8% to 6.5% for different fossils, different bone materials, different bone regions, and different stratigraphic positions. When the samples are taken from the same bone region, Then you obtain concordant PMC for comparing appetite and collagen, for comparing appetite and total organics. You see these values. And for comparing organics with extracted humic acid, with contaminant. And concordant PMCs for collagen and total organics. Furthermore, you get a good agreement between beta mass spectroscopy and mass spectrometer and accelerated mass spectrometer. Fourth result, the appetites from all samples have concordant delta C13 values between -3 and -10, with one exception, and the collagen, the organics, and shared bone exterior from all samples have concordant delta C13 between -17 and -28. And finally, megafauna have similar PMCs. Dinosaurs, plant fossils have less than them. Now I want to discuss the origin of these results, because surely the probability of contamination has to be considered here. We have the possibility that external CO2 is introduced as calcium carbonate via water diffusing into the bone, and external organic material like humic acid is well known. However, we believe that this probability is low because of the following reasons. First of all, we have observed that there's a PMC concordance of organics and of extraction of what you extracted as humic acid. And if the PMC value of this organics stemmed entirely from the contaminant, then we would expect an intermediate PMC between contaminant and the organics, which is supposed to have no carbon-14 at all. However, they were almost the same. Then we had this PMC concordance between the small sample size and the large sample size. Contamination, which might be very inhomogeneously distributed among the bone, would not deliver such equality. Then we have, which is most important, the PMC concordance of different chemical fractions: minerals, collagen, and total organics. And this is considered, according to Jakinski, as a very sure criterion that this data is reliable. Okay, and then we have delta C13, which is typical for C3 eaters. This is between -80 per mil to -21, and we had -20. This is our result, and this one is our result, and this is where typically C3 eaters are lying. This is then considered as reliable for dating. Then the matrix on top of the Triceratops had a very low PMC value. If it were the reason for contamination, then it would have been necessary that a lot of material would have been deposited inside the bone. A huge contamination would have been needed. And furthermore, the same pre-treatment procedure as was applied to the dinosaurs was applied to the plant fossils. But the plant fossils delivered only less than 1% C14. So if contamination was at least to the amount of several percent not removable, this would have occurred in these plant fossils too. But here we see very clean samples. And another argument was that the concentration of carbon, when we measured it in the vicinity of the fossils, it becomes smaller as the further we get away from the fossil. And this indicates that the carbon is migrating away from the fossil, not vice versa. And also an interesting yet still not understood result, if we sort all of our results according to the PMC value, then we obtain that the PMC values are divided into 4 distinct groups, and the origin is unknown. Perhaps it is a fractionation effect. You find the same dinosaur, one fraction of the same dinosaur can be here or here, for example. Here is mainly the plants, and here you have megafauna and dinosaur, as you have here and here. However, inside these groups, you have a very, very good concordance. And this is unlikely that the contaminant would sort in such groups. We believe that this is a bone property and not from outside. So let me conclude and suggest further work. The most important result we have found, C14 in dinosaur bones, And we are sure that this is not coming from contaminants, but it's endogenous. The results confirm recently reported observations of soft tissue, blood cells, and sequenceable proteins in dinosaur bones, and even writable ink in a fossil squid. Concordant PMC of dinosaurs and megafauna has been found, which has far-reaching consequences. The results can be explained by a rapid horizontal strata formation, as is observed in laboratory experiments with moving water. Further analysis of more dinosaur bones is recommended to confirm the finding of proteins and of C14. Samples from museums and field collections would be suitable. Thank you very much for your attention.